Okay, today we're going to talk about H9G.2 transition matrices and Markov chains. Prior to doing this assignment, you should have done H9G.1, the revision village, which talks about Markov chains. It's very, very useful to watch the revision village video and do that handout first before this. In this example, we're going to be using the letter D for dry and W for wet. So in this example, we've got a Markov chain, and we're going to do some probability here. So if we in this situation, if it's dry, then the next day is a 60% chance that it's going to be dry, and to be wet, it's going to be a 40% chance of being wet. And if it's wet, it's a 50% chance of being dry and 50% chance of being wet. Okay. So we're going to be discussing transition probabilities. So another convenient way is we're going to talk about the transition state diagram. That's this thing right here. This is a transition state diagram, and so we're going to go from transition state diagrams to transition state matrices, and I'm going to talk about how that works. Okay, so in this example, if it's wet, and so let's start off here. If it's wet and then it becomes dry, then we're going to follow this route right here. If it's wet and then it becomes dry, we're going to start at the W and then we go towards D. If it's wet and then it's going to stay wet, I'm going to go this orange pathway. Basically, it's wet, and then I do this loop-de-doo and stay at the W. So if it's wet and stays wet, I do this loop-de-doo, W, and stay at W. If it's dry, and then it's going to stay dry, I'm going to go this route, where it starts at D and does the loop-de-doo, and we stay at dry. And if it's dry and goes to wet, then I'm going to start in dry and I'm going to go to wet. Okay. And then how this matrix works is if we start at dry and the current state, if we're currently at D, because it's currently dry, and now it's going to stay dry, I do this pink loop-de-doo. If it's currently wet, and then if it's currently wet, and then it's going to become dry. If it's currently wet and then it's going to become dry, I'm going to go this yellow pathway. Okay. If it's currently dry and then going to be wet, I'm going to go from the D to the W. I'm going to use the blue pathway. And if it's currently wet and then it's going to stay wet, I'm going to do this orange loopy-de-doo where it starts wet and it stays wet. Okay, you might want to replay that again, and the revision village guy does a really good job with that. Okay, investigation 9. So here we've got a tree they put together. In this current example, it says, okay, find the probability that if it's dry, it's also going to be dry 2 days from now. Okay, so if it's dry now, to be dry 2 days from now, I'm either going to go this pathway here, which is 0.6 times 0.6, or I'm going to go this pathway here, which is 0.4 times 0.5, right? Because if I do this pathway after 2 days, I am going to be dry here, and if I go this way, I'm dry here. Okay, and so I've got a 56% chance that it's going to be dry after 2 days if we started off dry. Okay, now here to find the probability that if it starts off dry, that it's going to be wet after 2 days. So if it's going to be wet, we're starting off dry, We're starting off here, and the probability that it's going to be um, wet 2 days from now. So if I go this way, it's wet 2 days from now, and which is 0.6 times 0.4. And if I go this way, it's going to be wet 2 days from now, which is 0.4 times 0.5. Okay, so this is the probability that it's going to be wet 2 days from now. I'm just looking at this W right here. 2 days from now is here and here. Now, you should do a check, because I've gone every pathway, right? Does 0.56 plus 0.44, that should equal 1, shouldn't I? Right? It's either going to be dry or wet. There's no other choices, right? Okay, so I remade the tree for question 1, and what's the probability that it's wet? We're starting off wet, and it's going to be wet 2 days from now. So if I'm going to go wet, dry, and then wet, that's this first pathway. I guess, well, I guess it's the second 0.5 times 0.4, and then I could go wet and then wet again. That's going to be 0.5 times 0.5. So we've got a 45% chance that it's going to be wet. And I just did what I did over here, which is we know that these have to add up to 1, so I did 1 minus 0.45. So this is the probability that it's going to be dry 2 days from now. So going this pathway and this pathway. Okay. All right. So we're going to take this matrix, and we used it from the previous page. And if we square it, okay, so let's enter this matrix. 0.6, 0.5, 0.4, 0.5. Okay, so second mode to quit. Okay, so second matrix, I'm going to hit matrix A, and we want to square this. So squared. And then I get this. And notice the second one here and this one here matches this. So this represents that, what's the first? Okay, so this is dry and this is wet, and this is dry and this is wet. So the probability, this first one, the probability that we started off wet and we ended up wet, is what started off wet and ended up wet, is 0.45. We started off wet and ended up dry is 0.55. Okay, so basically what I just showed here is the entries of the matrix are the same as the probabilities found at the end of the branches. So here we found the probability at the end of the branches when we went dry to wet and wet to dry. So if we started off wet and then we want to end up wet after 2 days, we got 0.45, and this is the same result if we started off wet and ended up wet. And same thing, if we started off wet and ended up dry after 2 days, we get 0.55, and we found that using the tree, and we found this using the matrix. So we basically took our transition matrix and we squared it. Okay, so we found that the end of the branches in 1 and 2 matched the matrix. Okay, so what is more effective? And the matrix multiplication is more effective. Okay, question 6. You can hit pause and copy this down. I'm going to read it through you. So how do we interpret the value of the matrix t to the power of 3? So basically this is saying after 3 days, what is the current state? So if we start off dry, the probability that we end up dry is going to be this guy here. If we start off dry and end up wet, that's going to be this value here after 3 days. So if we cubed it and that sort of thing. Okay, so how can you interpret our results when multiplying by the transition matrix? So each time we multiply the transition matrix to itself, it adds another time period. So when we squared it, it was 2 days later. When I cubed my transition matrix, then that was the equivalent of the results 3 days later. Okay, so what does the n power of t to the n? So the power here represents the number of time periods that we're going to do this. Okay, how can probability of Markov chain be representative? You may want to hit pause if you want to copy this down. The probability of Markov chain can be represented by the transition matrix and the probability for the various states of the system after n transitions. Okay, so most important on this part right here, the transition matrices are going to be square. Okay, it's not going to be a rectangle, or the rows and the columns have to be the same. The other thing is the sum of the columns has to add up to 1. Let's look back and see what we have here. Notice 0.56 plus 0.44, that adds up to 1. These guys here adds up to 1 as well. And here, the original one, 0.6, 0.4, that adds up to 1. 0.5 and 0.5, that adds up to 1. And we should know that with probability, the probabilities always add up to 100%. Okay, and okay, so example 10 was done for you as a really good example. So so I'm just going to take a random one here. So if I start off with C and I go to O, that means I'm going to start off at C and I'm going to go to O, and that's why I have the 0.2 there. Let's pick another random one. I'm going to start off at O and go to I. So if I start off at O and go to I, notice that's 0.3. And let's pick another one. If we start off at I and go to O, we start off at I and go to O, we get 0.35. So I hope this helps you visualize what it is we're doing. And so we may start off with a transition diagram and ask you to rewrite it as a matrix, or start off with a transition matrix and ask you to rewrite it as a diagram. Okay? So let's look at our problems for practicing here now. Okay. So if we're starting off at state X and ending up at state X, I'm going to do a loop-de-doop, boop-doo-doop-doo-doop, and I'm going to that's going to be 5/11. If I'm starting off at state Y and ending at state X, so we're starting off at Y and headed towards X, and that's going to be 1/5. If I'm starting off at state X and going to state Y, I'm going to go from here, and now I'm going to end up at Y. Make sure you put those arrows, because otherwise it won't make too much sense. Lastly, let's do a color here. If we're starting off at Y and ending up at Y, I do a loop-de-doop, doop-de-doop, and there I'm starting at Y and ending at Y. Okay, you might want to check your work on this guy here. Let's look at this guy. So in this one here, remember that the columns here have to add up to 100%. So if that's 0.25, that's got to be 0.75. If this is 0.2, that's got to be 0.8. Okay. I could have looked at the picture here. Starting at C, ending at C. That means I'm going to look at the loop-de-doop guy. starting at P, ending at P. That means I'm going to do a loop-de-doop here. Okay. So calculate after 3 sessions or days or whatever the heck it is, um, uh, weeks. So calculate the transition state after 3 weeks from now. Okay, so if it says 3 weeks from now, then that means we're going to be using the power of 3. Okay, so you should be familiar with entering the matrix 0.75, 0.2, 0.25, 0.8. Okay, second mode to quit. Second excellent matrix. We're going to do matrix A, and we're going to do this to the third power, and then we get our transition matrix. Okay. Okay. Might want to hit pause and check your work. Question 4 was kind of tricky. So if you didn't get question 4, I think it's unlikely they would have one of these on the test. Basically, if we're starting with only whites and we're going to take out one of these marbles and switch it around, we have 100% chance that it's going to be mixed. If I take one of these and I move one of the marbles around. So if I take one of these marbles around in state in the first, this is our first state, the current state, and if we start off with just white marbles, then we have 100% chance that if we move something that it's going to be mixed. If we start off with mixed, then we have a 1/4 chance that it's just going to be all white in the first one. We have a 1/4 chance that it's going to be blue in the first one, and a 50-50% chance that it's going to stay mixed. And then if we start off with only blue, then we have a 100% chance that it's going to be mixed. Same sort of thing when you mix it with 3. This is much more tricky. Okay. Okay, same process with setting up the transition diagram. You might want to hit pause and check your work. Okay, you may want to hit pause and check your work. I hope this is helpful.